Welcome back, dear children. Now we will move to the next topic, thermal expansion. Okay, so what do you mean by thermal expansion? Already we have learned that all the substances expands on heating and contracts on cooling, isn't it? So that is a general thing. When you are heating an object, it expands, and when you are cooling, it contracts. Now, what about the rate of expansion in the case of solids, liquids and gases? In a solid, the particles are so tightly packed, so the rate of expansion will be less. But when you are moving to gases, the molecules are free to move, so rate of expansion will be maximum. Okay, so all the substances expands on heating and contracts on cooling, and the rate of expansion is minimum in solids and maximum in gases, and the rate of expansion will be in the midway in the case of liquids. Okay, so this is a general concept, but there is an exception. Okay, water shows an exceptional behavior between 0 degrees Celsius and 4 degrees Celsius. Okay, all the substances expands on heating and contracts on cooling, but just opposite takes place in the case of water at a temperature between 0 degree and 4 degrees Celsius. In all other temperatures, it will go according to the usual fact, but at a temperature between 0 degree and 4 degrees Celsius, water shows an exceptional behavior, and that is known as anomalous expansion of water. Okay, it is known as anomalous expansion of water. Instead of contraction, it will expand, and instead of expansion, it will contract between the temperature 0 degree and 4 degrees Celsius. Okay, now we will check what it is. Suppose consider water at 10 degrees Celsius. Okay, we are taking water at 10 degrees Celsius when water is cooled. So substances contracts on cooling, isn't it? So water also will contract till 4 degrees Celsius. Okay, till 4 degrees Celsius water will contract. Then once it reaches 4 degree, what happens is, again if you are cooling, instead of contracting, it will expand till 0 degree. Okay, when you are cooling water from 4 degrees Celsius, then actually it should contract, but it expands till 0 degrees Celsius. Okay, then after 0 degrees Celsius, again it will go to the original part. That is, substances expands on heating and contracts on cooling. Clear? And at 0 degree, what happens? Water gets converted to ice. So when water is cooled from 4 degrees Celsius to 0 degrees Celsius, it will expand. Now the reverse thing, you are taking water at 0 degrees Celsius. Okay, when water at 0 degrees Celsius is taken and when it is heated, actually it should expand. But instead of expanding, it will contract till 4 degrees Celsius. Okay, water will contract till 4 degrees Celsius. 0 to 4 degrees Celsius, and after 4 degrees Celsius, what happens? It will start expanding. Okay, so this is a special property shown by water, and that is known as anomalous expansion of water. Okay, so water at 4 degrees Celsius, when you are cooling at water at 4 degrees Celsius, it expands from 4 degrees Celsius to 0 degrees Celsius. Water taken at 0 degrees Celsius will contract when you heat. That is from 0 degree to 4 degrees Celsius. Okay, so is it clear about anomalous expansion? Okay, now so when you learn the definitions related to water, you can see that in all the definitions or in equations, when you are writing the equations related to the density of water, usually they will give it as density of water at 4 degrees Celsius. In order to calculate this relative density and all, when we are learning about relative density and all, you have seen it as 4 degrees Celsius. Density of water at 4 degrees Celsius. So why are we writing it as 4 degrees Celsius? Because water has maximum density at 4 degrees Celsius. Okay, density of water will be maximum at 4 degrees Celsius. So when we are doing the experiments, or when you are writing the equations, then usually we will write water at 4 degrees Celsius, density of water at 4 degrees Celsius, because water has maximum density at 4 degrees Celsius. Why? When you are cooling water at 10 degrees Celsius, it will contract. When it reaches 4 degrees Celsius, contraction will be maximum. If contraction is maximum, means the molecules came closer. That is what happens to the density. Density will be maximum and volume will be minimum. Okay, density will be maximum and volume will be minimum at 4 degrees Celsius. Reverse also you can say, when you are heating water at 0 degrees Celsius, at first it contracts till 4 degrees Celsius. So at 4 degrees Celsius, contraction will be maximum. Contraction is maximum means what about the density? Density will be maximum. Molecules are coming closer means density is maximum. Since the molecules came closer, what about the volume? Volume will be less. Okay, so water will be having maximum density and minimum volume at 4 degrees Celsius, and this is known as what? Anomalous expansion of water. Okay, so is it clear? Now we are having two graphs, graphical representation, in order to show the density as well as volume of water at this 4 degrees Celsius. Okay, so in the first case we are considering a graph with temperature in the x-axis, and you will be considering volume in the y-axis. So temperature, let me take it as 0, 2, 4, 6, because 4 has to be visible, isn't it? Now here it is volume. Now when temperature increases, what happens? You are increasing the temperature from 0 degrees Celsius. When you are heating water at 0 degrees Celsius, what happens? It contracts, isn't it? It contracts means its density increases whereas volume decreases. In the y-axis I have taken volume. So what happens? This will be the shape of the graph. Why? Why is it coming like this? Here we have taken temperature in the x-axis and volume in the y-axis. When temperature increases from 0 degrees Celsius, instead of expanding, water contracts till 4 degrees Celsius. So when it contracts means what happens? Molecules are coming closer. That means its volume goes on decreasing, and volume will be minimum at 4 degrees Celsius. After 4 degrees Celsius, what happens? It starts expanding. When it starts expanding, naturally volume increases. Okay, so this graph is important. This graph represents the relation connecting temperature and volume. In the case of water, from temperatures when it is heated from 0 degrees Celsius. Now one more graph is there. Here we have taken same temperature, but here it will be density. Okay, temperature and density. Here also let me mark 0, 2, 4, 6, etc. Now what happens to the density when water at 0 degrees Celsius is heated? When water at 0 degrees Celsius is heated, instead of expanding, it will be contracting, isn't it? So when it contracts, what happens? When it is contracting means its density starts increasing, and its density will be maximum at 4 degrees Celsius. Okay, so here this is the 4 degrees Celsius. So this will be the shape of the graph. Okay, so when the temperature increases, density slowly increases, because from 0 to 4 degrees Celsius water is contracting. So density slowly increases, and when it reaches 4 degrees Celsius, what happens? Density will be maximum. We will be having maximum density at 4 degrees Celsius. After that it starts expanding. That means density decreases. Okay, so be thorough with these two graphs. Temperature, volume as well as temperature density. And what you should remember, density will be maximum and volume will be minimum at 4 degrees Celsius. So this will be the shape of the graph. Okay. So is it clear now? Now we will move to Hobbs apparatus. Okay. Hobbs apparatus is used in order to prove anomalous expansion of water. Okay. To prove anomalous expansion of water, Hobbs, it is the name of a scientist, and he devised a vessel, and that is known as Hobbs apparatus. Okay. So using the Hobbs apparatus, it will be clear that water shows anomalous behavior between the temperatures 0 to 4 degrees Celsius. Now, for this, he has taken a cylindrical glass vessel. Okay. So a cylindrical glass vessel is taken. Will be having a cylinder. Okay, cylinder. You will call it as a cylinder. Now, let this be the stand of the cylinder. Then, in the center, we are keeping a trough. Okay. Do you know what is a trough? Trough means it is an open vessel. That is known as a trough. So, in the center, a trough is kept. Okay. An open vessel is there in the center. Then, 2 thermometers are kept. We will be making small hole, and 2 thermometers are kept, one below the trough and the other one above the trough. Okay, and I think okay, so this is a cylindrical vessel with its, or it is a cylinder. You can consider it as a cylinder with its tank. Then we have a trough. Okay, trough means an open vessel. It is fixed in the center. Then above and below the trough, we will be having what? 2 holes to insert 2 thermometers T1 and T2. Now, this trough will be filled with a freezing mixture. Okay, trough will be filled with a freezing mixture. Do you know what is freezing mixture? Freezing mixture means it is a mixture of ice and salt in a particular ratio, and this freezing mixture is used in order to make kulfis and all. Okay, so in a particular ratio we are taking ice and salt. That is known as freezing mixture. So this trough will be filled with the freezing mixture, and the cylinder will be filled with the water. Okay, water is taken in the cylinder, and we will be having freezing mixture in the trough. So this is our arrangement. That is a cylinder or a glass vessel. Okay. Now in the center we will be having a trough. That is an open vessel is there. Above and below the trough we will be having 2 holes to insert the thermometer. 2 thermometers T1 and T2. Now this trough will be filled with a freezing mixture. That is a mixture of ice and salt in a particular ratio. Then we will be having water filled inside the cylinder. Okay. Now, first we will check the temperatures shown by the thermometers T1 and T2. So let both the thermometers shows the room temperature. When it is kept on a room, usually you will be getting the room temperature, isn't it? At first, T1 and T2 will be showing the same room temperature. After some time, what you can see is the temperature shown by the thermometer T1 remains as such, but T2 goes on decreasing. Okay, it decreases till 4 degrees Celsius and then it stops. After that, you can see that the temperature shown by T1 will start decreasing, and finally some ice pellets can be seen. That is, even it reaches a temperature of 0 degrees Celsius. But the temperature shown by the thermometer T2 will be 4 degrees Celsius itself. Okay. So I will repeat. We have 2 thermometers. At first, both the thermometers will be showing the room temperature. After some time, the reading shown by the thermometer T2 goes on decreasing, and it reaches 4 degrees Celsius. After that, what happens? By that time, T1 will be same. No, there won't be any change in T1. After some time, once the reading shown by the second thermometer is 4 degrees Celsius, you can see that the temperature shown by T1 slowly decreases, and finally 4 degree, 3 degree, etc. And finally what happens? You can see small ice pellets on the surface. Okay, so this is our experiment. T1, the temperature shown by T1 will be so less, but the temperature shown by T2 will remain as 4 degrees Celsius itself. Okay, now what is the reason here? So, at first I told you both the thermometers are showing the room temperature. That is, it is placed on a in a room, isn't it? So the normal temperature of the room will be shown by both the thermometers. Now, in the center we are having ice, isn't it? So this ice will cool the water present near its surface. So when it cools, what happens? Here, when water cools, all the substances expands on heating and contracts on cooling. So when it cools, it contracts. That means its density increases, isn't it? So here the water molecules present near the center gets cooled, and based on that the temperature shown by the thermometer falls. The ice present in the trough or in the freezing mixture will cool the water present in the central portion. So based on that, what happens? The temperature shown by the thermometer T2 will fall. So when it cools, water contracts, isn't it? It contracts, and when it contracts, what happens? The water molecules present here will be less denser than that, isn't it? When water or any object is contracting, means its density increases. Denser particles will always go down and lighter particles will come up. So the molecules which becomes cool, that is, the molecules present in the center will become cool and get denser, and those denser particles will go down and the lighter molecules will come up to the center. That gets cooled, again it becomes denser particles will go down, and finally what happens? The entire molecules, water molecules present in this region gets cooled up to a temperature of 4 degrees Celsius. What is the specialty of temperature at 4 degrees Celsius? Water will be having maximum density at 4 degrees Celsius, isn't it? So the water present in the bottom portion of the cylinder will be having a temperature of 4 degrees Celsius. 4 degrees Celsius, water is having maximum density. Denser particles will always stay down, isn't it? Again, it won't go up. Lighter particles will move up and denser particles will stay down. So this complete portion will be having a temperature of 4 degree. At 4 degree, water is having maximum density. So again, it won't come up. Okay. So this complete region will be having a temperature of 4 degree, which is shown by the thermometer, and it will remain as such. What about the water molecules present on the top? It is hot, isn't it? That means it is not as cool as the water present in the bottom part. So slowly the water molecules present in the top region will get cooled by the ice from this trough, and the temperature shown by T1 goes on decreasing. It reaches 4 degree. When it reaches 4 degree, actually it should come down. But in the bottom also, entire water is at a temperature of 4 degrees Celsius. So all are equally denser. So the molecules can't come down, isn't it? They will remain there itself. So again, due to the ice present here, what happens? The molecules present in the water molecules in the upper region, again it gets cooled, isn't it? So when it cools after 4 degree to 0 degree Celsius, what happens? 4 degree to 0 degree Celsius, what happens there? it will expand, isn't it? At 4 degrees Celsius, water is having maximum density. Again, when you are cooling, instead of contracting, it will be expanding. So it starts expanding, that means it becomes lighter. So the temperature falls and it reaches 0 degree, and when it reaches 0 degree, what happens? Water gets converted to ice and small ice pellets can be visible there. Okay, so this proves anomalous expansion of water. Okay, so once again I will give the explanation. At first, both the thermometers T1 and T2 will be giving the same temperature, that is room temperature. Now, due to the ice or the freezing mixture present in the center, the water molecules present in the central region gets cooled and their temperature falls, and that will be shown by the thermometer T2, that is from the room temperature the temperature falls. So at first the molecules present in the central region gets cooled, means it gets contracted, will be having more density, so it goes down. So the water molecules with less density will go up, gets cooled, it will come down, and finally this entire region will be having a density at 4 degrees Celsius. That is, the temperature will be 4 degrees Celsius at this entire region. At 4 degrees Celsius, water is having maximum density. Again, what happens? It cannot go up. The density of molecules of water present in the upper part is less than that, isn't it? So, again, the water present in the upper region starts cooling. You can see that the temperature shown by the thermometer T1 falls. When it reaches 4 degree, the entire water present in the cylinder is at 4 degrees. So again the molecules cannot move up and down. So due to the ice present in the freezing mixture, again what happens? The water present in the top region gets cooled and its temperature slowly falls and it reaches 0 degrees Celsius. Okay. By that time, the temperature shown by this thermometer will be 4 degree itself. Why? Because at 4 degree water is having maximum density. These particles cannot come up again to get cooled. Okay. Only these particles can move. Because at 4 degree it is having maximum density and it will stay there itself. Once the entire thing gets converted to 4 degrees Celsius, then only what happens? It starts expanding. Water will start expanding and only the particles present in the top will expand. Because here it is having more density, so it will be thickly or tightly packed there. Okay, so I hope it is clear with the Hobbs apparatus. No need to by heart the experiment and all, but you should know what it is. Okay, questions can come from that part. Now, the last thing is about the consequences of anomalous expansion of water. So, two consequences are given here. First one is about the survival of aquatic life. When you move to the polar region or cold countries, you can see ice pellets or ice cubes on the surface of a pond or a river. But again there, the aquatic lives will be there, or aquatic life survive beneath this ice. So what is the reason? In cold countries, you can see ice on the surface of rivers or ponds. Then how can the fishes or other aquatic organisms live if it is completely ice? So what is the reason? When the atmospheric temperature falls, what happens? The temperature of water also will fall. There, the temperature of the entire water will become 4 degrees Celsius at first. Once when it becomes 4 degree, density will be maximum and the molecules at 4 degree with maximum density will be in the bottom portion. Then the other particles or the water molecules present in the top, they will be also having 4 degree first. So the entire water will be getting a temperature of 4 degrees Celsius. Again the temperature falls. The denser water molecules in the bottom will remain at 4 degrees Celsius itself. But on the surface what happens? These water molecules, the temperature of the water molecules will again fall. Instead of contracting, they will expand after 4 degrees Celsius. It becomes lighter. So again it can't go down. Okay. So the temperature of water below the water surface will remain as 4 degree itself, but near the surface the temperature will fall below 4 degree, 0 degree and gets converted to ice. And this is a reason for the survival of aquatic life. Okay, you will be seeing ice near the surface or ice on the surface of rivers and ponds, but beneath that we will be having water at 4 degrees Celsius, which is denser. So aquatic life can survive there. Okay. Now another one, during the, if it is too cool at that time, the water pipes may burst. Okay. In cold countries, water pipes may burst at cold nights. Okay, what is the reason? When the temperature fall, actually at first water will be contracting, and when it reaches 4 degrees Celsius, contraction is maximum, isn't it? Now again what happens? Again when the temperature falls from 4 degree to 0 degree, instead of contracting, water will expand. So when it expands, that much pressure cannot be, the pipeline cannot withstand that much pressure and it pipelines may burst. Same thing happens in the case of crops also. There is the capillary tube in the crops, isn't it? So when the temperature falls below 4 degrees Celsius, it will expand. Okay, water present or the liquid water present in the capillaries will expand, and this will result in the destruction of the crop. So these are the consequences of anomalous expansion of water. Okay. So once again, aquatic life will survive beneath the water surface because there the water will be at 4 degrees Celsius. At 4 degrees Celsius, water has maximum density. So this denser particles will be there, or denser water molecules will be there in the lower part. Denser particles will always go down, and the temperature, when the atmospheric temperature falls, the temperature of water near the surface will fall below 4 degrees Celsius, becomes lighter, gets converted to ice. Then again, in the case of water pipes, so in cold countries, if the temperature falls below 4 degrees Celsius, water will start expanding. It results in the bursting of the water pipes. Same thing in the case of plants also. Capillaries will be having water. When the temperature falls below 4 degrees Celsius, it will expand, resulting in the destruction of the crop. Okay. So with this, we completed section A. Now children, here also no need to write the lecture notes. I need the question answers. Okay. So together 18 question answers are there. For few question answers, the answers are given. No need to write that. Rest you should write in your notebook. Okay. Drawings are there. In that, question number 17 is not needed. Draw a diagram showing the temperature of various layers of water in an ice covered pond. So that is not needed. Okay. Question number 17 is not needed. Then rest we need. With the diagrams you should do. Okay. So study this portion, complete the notes. Okay. Thank you children.